We're in section 3.4, and I'm just going to call this more parallel lines. We're just adding some information about what we know about parallel lines. So before we get into the new stuff, let's recap really quickly. Just what we've talked about so far. So we've said that if we talked about lines intersecting. That was our very first topic. So if we have two lines and they're intersected by a transversal, we called the space between the lines, between the two lines, what do we call that space? The interior. So this is the interior. And we call the space outside the exterior. And we called the line, we gave this line a special name. We went over it again just yesterday, I think. What do we call this line? Our transversal. And then we named some special pairs of angles. We talked about alternate interior angles. We said alternate means opposite sides of the transversal, and they're inside the parallel lines. Alternate exterior angles, outside the lines, opposite sides of the transversal. And then consecutive, or same side, interior and exterior. Same side meaning same side of the transversal. So we named all these special angles. Then we talked about what happens when the lines are parallel. Special relationships between the angles happen when the lines are parallel. So just a couple of examples. We knew that alternate interior angles were congruent. The one we used on the opener was same side interior angles are supplementary. So we came up with a bunch of relationships with those angles. And then we talked about what happens if we don't know that the lines are parallel yet, but we know some things are true about the angles. How do we prove that the lines are parallel? So if we know that these special relationships happen with the angles, then that guarantees us that the lines are parallel. That's what we talked about the last time we met. So today we want to talk about the very bottom of your graphic organizer. So on the bottom left, you have some lines drawn there. And we're going to talk about what happens in that situation. So let me draw the picture up here. So we have, on our graphic organizer, we have something like this. And our lines are L, M, and N. And what we're going to say, and in your graphic organizer there's a misprint. It should say L is parallel to M and L is parallel to N. So these two lines are parallel. L is parallel to M and L is parallel to N. So if that happens, then M is parallel to N. So if these two lines are both parallel to the same line, then they're parallel to each other. So that's what goes in the box there at the bottom of your graphic organizer. So you want to change the second little parallel pair there. It should say L parallel to M and L parallel to N. So M and N are both parallel to line L, so that guarantees us that they're parallel to each other. So let me draw a transversal, and we'll just talk about how we would be sure that this is true. So there's my transversal between L, M, and N. What do we know if L is parallel to M? What would we know about angle 1 and 2? If line L and line M are parallel, what do we know about angles 1 and 2? They're supplementary. Okay? And if L is parallel to N, what would we know about angle 1 and 3? So just ignore line M. L is parallel to N. They're also supplementary. So we're saying that angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary. So I could say the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 3 plus the measure of angle 1 equals 180. So I'm adding some number to angle 1 and getting 180 here, and here I'm adding some number to angle 1, the measure of angle 1, and getting 180. So what does that tell us about angle, how angle 2 and 3 would be related? They would be congruent. So that would be angle 2, right? That would have to be congruent. So now I have what kind of angles here on these two for line M and N? Alternate interior, and we just decided they were congruent. So what does that guarantee us about the two lines? If alternate interior angles are parallel, or alternate interior angles are congruent, then the lines are parallel. So that would be how we would go about proving that. These two are supplementary, these two are supplementary, so these two have to be congruent. Well, these are alternate interior angles, so that guarantees us that line M and N are parallel. So it's almost like a transitive property for parallel lines. L is parallel to M, L is parallel to N, so M and N are parallel. Almost like a transitive property. Questions on that? Nothing really groundbreaking or strange or different. All right, let's look at the next box on your graphic organizer. So your picture for the next box looks like this. And here we have line L, M, and N. And let's remember what these little squares on the lines mean. What does that mean about the lines? They're 90 degrees, they're perpendicular. And our symbol for perpendicular, we use, I think we've talked about it before, and it's in the graphic organizer. And there's another typo here. It should say L is perpendicular to M. This little upside down T means perpendicular. They make a 90-degree angle. And it should say L is perpendicular to N. So let's make a guess about what that tells us about M and N. If these two are both 90 degrees, what would we know then about line M and line N? They have to be parallel. M is parallel to N. So that's what would go in that last box on your graphic organizer. And this one's really easy. For these two lines, for line M and for line N, what kind of angles are these two angles? What was it? They're right angles. And just what did we name them for our two lines cut by a transversal? So I call this angle 1 and this angle 2. What do we name angles that were situated like this for our lines? One is inside, one is outside. So there was only one pair where we had one angle inside and one angle outside. You remember? Corresponding. If I took this line and shifted it all the way over here, those angles would be sitting right on top of each other. So we call those corresponding angles. So angle 1 and angle 2 are corresponding. They're both 90 degrees, so angle 1 is congruent to angle 2. And if corresponding angles are congruent, then we know that the lines are parallel. So that one's really easy. The reason for that. So now we have both sets of graphic organizers complete. We know about our different angles, how we name them, how they're related, if lines are parallel, and we know several different ways to decide that lines are parallel. So what I want to do is just do a couple of examples with these kinds of ideas. This is not really that different than what we've already done. Just adding a little bit of detail. A couple of examples, and then we'll be done for today. So let's look at a couple of examples. Let me draw a picture here. There's my picture, and I'm going to call this A, B, C, and D. And I'm going to label some angles here. So this is 68 degrees. This is 22 degrees. This is 35 degrees. And this is 55 degrees. And I'm going to say, what can we figure out? So given this information, what can we figure out? So all we have are some segments drawn and some angles labeled in there. Anybody see how we could go about figuring something out? Let's look at these two angles. Anything special about those two angles? They add up to 90. 68 plus 22 equals 90. So this whole angle is 90 degrees. What about these two angles? 35 plus 55 is 90. So this angle is 90 degrees. So if I redrew this really quickly, I'm just going to make a quick sketch here. Without these little crosses in here, here's what I have. A, B, C, and D. So what do we know here? Here are two segments. They intersect this other segment, both at 90 degrees. So what does that tell us? About segment AB and segment BC. They're parallel. These both intersect this second line at 90-degree angles, so that means they have to be parallel. Because both of these angles are 90 degrees, That means that these two segments have to be parallel. Does that make sense what we did there? Okay. Let me backtrack just a little bit before we do our other example. Let's go back to this. Would this be true if we were not in a plane? If we were not on a flat surface? If two lines intersect a third line at 90-degree angles, they're parallel. Would that be true if we weren't in a plane? If we were just in space? Abby says no. Why not? Well, can you think of an example that would make that not true? If we're not on a plane. So we could have a shape in space, just out in 3D, that looked like this. But let's say we had a line like this, okay, and a line like this. So there's one line that intersects us at 90 degrees. How could we make another line that intersected this line at this point at a 90-degree angle that wasn't parallel to this one, if we're in 3D? How about straight into the board like this? Wouldn't that make a 90-degree angle with that line? Yeah? Or this is my pen and this line parallel? No? What did we call those kinds of lines that aren't parallel but never intersect? Skew. So if we're in space, this doesn't necessarily work. If we're in 3D, this wouldn't necessarily work because we could have skew lines. We could have a line going directly out of the board through that point that would still make a 90-degree angle with this line, but not be parallel to this one. So we have to be in the plane, on a flat surface for this to work. All right, let's look at one last example. Just wanted to make sure that we saw that. Let me draw another picture, and this is the same. We're going to ask the same question here. What do we know in this situation? Call these lines A, B, C, and D. So from this information, what can we figure out is true? What about line A and line B? How are those two lines related? They have to be parallel. They're both perpendicular to line C, so they have to be parallel. How about line C and line D? They're also parallel. They're both perpendicular to this line, so they have to be parallel. What could we say about line A and line D? What if I extended this like so, so it intersected? What angle would this have to be? That would have to be a 90-degree angle. Since these two are parallel, and line C hits this one at a 90-degree angle, line D would have to hit line A at a 90-degree angle, so we could say line A is perpendicular to line D. Even though they didn't draw it so they intersected, if we drew it out and they intersected, we'd be able to figure out that they are perpendicular. And then we'd have a nice shape in here that would be a rectangle. Could be a square if all the sides were the same, but we'd have a rectangle because all of our angles are 90 degrees. And we'll get to talk about shapes and how we make up different shapes in just a little bit. We're getting close to talking about all our different shapes. So questions on this? Just adding a tiny little bit to what we already know about parallel lines. Okay.